Hi there. In this video, we're going to talk about measurements and errors in physics. And remember, in a previous talk, we talked about how every measurement we have is known to only so many significant figures, and how many significant figures we have in our number depends on the device that we're using. So before we look at some examples, I want to talk about a couple of things which are important in our discussion. So the first thing I want to talk about is something called the least count. And the least count is just the smallest printed increment on the device. Now, the device could be anything. It could be a metric, a digital scale. It could be a ruler, a meter stick. It depends on the device. Okay, so that's the first definition I want to introduce. The next is the instrument limitation error. And this is the error incurred when you're taking a measurement with a specific device. So the error incurred when measuring with a device. Okay, so these are our two definitions. Now let's see how we can use these two things. So let's look at an example. I have a picture here somewhere I can paste in. Just give me a second. There we go. All right, so we have, well, hopefully you've all seen one of these in your life. This is just a ruler. And this is an example of something we called an analog device. So let's label that analog devices. Okay, let's just highlight that. All right, so let's look at this ruler. Let's figure out what the least count is. So if you recall, the least count, and from now on I'm going to just represent the least count as this acronym LC. Remember, it's the smallest indicated measure on our ruler, and if you look at the markings on it, the smallest unit indicated is the millimeter. So the least count on our ruler is 1 millimeter. And let's look at the instrument limitation error. Now I've just introduced a second acronym, but that is just this second definition we have here. So let me just write this in: the instrument limitation error and the least count. Okay, so remember, the instrument limitation error is the error incurred when you're taking a measurement. And for analog devices, we actually take this to be just half the least count. So this is true for analog devices. Okay, so in our case, the ILE is going to be half a millimeter, or we can write it as 0.0005 meters. All right, so that is analog devices. Let's look at digital devices. Digital devices we treat a little bit different. So I have a picture somewhere here. Let me just import this next picture. Where is it? There we go. Okay, So here I just have the picture of a screen that you might see on a digital scale. Now, if you note whatever's on this scale, it's weighing 132.6 pounds. If you note, the unit of measure here is pounds. It's not an SI unit, but we'll just work with it. So, for a digital device, the least count, or at least for this particular case, is going to be 0.1 pounds. It's the smallest digit that we are given in the display, which is, in this case, 1/10 of a pound. And the instrument of limitation error, for digital devices, it's just the least count. And I'm going to explain why it's different. So this is true for all digital devices. And so for our case, it's just 0.1 pounds. Okay, the reason why it's different is, actually maybe a better way of seeing this is going back to our ruler. So when we take a measurement with a ruler, I've chosen a really small increment here for this ruler, you can actually make an estimate somewhere between the two successive millimeter marks, which is why we take the ILE to be 1/2 millimeter. So for instance, let's say I have a straight line here that I'm measuring. Say it goes to here. Alright, so that black line that I just drew there, it looks like it's about 9 centimeters, and I would say it's 9 point, let's see, 1, 2, 3, 3, 8 centimeters. Oops. Centimeters. I don't know what's happening. Alright, so that line we can measure to be 9.38 centimeters. Now the millimeter mark is this 3, and I'm guessing the 8, which is why I choose the error to be this 1/2 millimeter. It allows some variation. You can make an educated guess with using an analog device on a precision smaller than what the least count is. However, for a digital device, you're at the mercy of the digits which are displayed in the display. So that's why we take the least count to be, the ILE to be equal to the least count. Okay, so once we've taken a measurement and we've figured out what the ILE is, how do we express this measurement? Well, let's go back to our ruler. So for this ruler, I've measured this line. So I said the line is 9.38 centimeters. So what I would do is the length of our line is 9.38 centimeters, and there's an error, and because of the device I used, I know how I'm going to quantify the error, so I just add that error on. And now it's plus or minus, because it's going to be, it might be slightly bigger, it might be slightly smaller. So I can write the length as 9.38.0 plus or minus 0.05 centimeters. Okay, so this 0.05 is just my ILE written in centimeters. And let's go back to our digital device here. So I can write the weight as 132.6 plus or minus what my ILE is, and in this case it's just 0.1 pounds. So here is how I would take into account the error in measuring something with this particular scale. Okay, so that is a quick explanation of errors and how they are incurred using devices. I hope this was helpful.